All right, you are welcome again. Today, let's consider determinants of matrices. Determinants of matrices. And then we're going to consider 2 by 2 matrix and 3 by 3 matrix. How you can find the determinant of 2 by 2 and the determinant of 3 by 3. Okay? All right. Let's go. Number 1, given that matrix A is equal to, we have A11, A12, A21, A22. They will say that, we have these to be 2 by 2, right? Okay. Now we say that the determinant of this matrix A, denoted as det A, that is determinant of A, is given as, we're going to have the main diagonals, the element in the main diagonals multiplied minus the element in the other diagonals multiplied. Hello. Now we have the main diagonal and the other diagonal, right? So the element in the main diagonal should be multiplied together minus the element in the other diagonal. That is to say, A11 multiplied by A22 minus A21 multiplied by A12. We have A11 multiplied by A22, that is the main diagonal, minus A21 multiplied by A12, that is the other diagonal. Okay? Yes. Now, let's go. Let's take an example. We say, given that we have matrix A equal to, we have 4, 3, 2, 2. So, we have to find the determinant of this matrix. So, the determinant of this matrix is going to give us the main diagonal. We have 4, 2. That is going to say 4 times 2 minus the other diagonal is 2 times 3. Then we say 4 times 2 minus 2 times 3. So 4 times 2 is 8. Then 2 times 3 is 6. So we have 8 minus 6 equal to 2. So the determinant of this matrix A is equal to 2. This is for 2 by 2. So anytime you are asked to find the determinant of 2 by 2 matrix, so you will simply multiply the element of the main diagonal minus the multiplication of the element in the other diagonal. Okay? Yes, now let's go. For 3 by 3 matrix, how can we find this? Okay, I'm going to show you 2 methods to use. Now, you can use the rule of Sarus, and also you can use the first principle. Okay, you can use the rule of Sarus and you can use the first principle. Now let's go. How can we use the rule of Sarus to find the determinant of 3 by 3 matrix? Now let's take this. Given that matrix A, we have A, B, C, D, E, F, G, H, I. That is 3 by 3 matrix. They will say that then the determinant of matrix A, denoted as det A, is given as, we have A, determinant of A. Now, we are going to write this matrix the way it is. The first column, the second column, the third column. Hello. Yes, you have the first column, second column, third column. Rewrite the first as the fourth, and then rewrite the second column as the what? The fifth column again. You get it? Now, the next thing you are going to do is this. I want to, from the main matrix that you have, draw the line to show you the main diagonal. That is AEI. That is the main diagonal in the matrix that you have, right? Now extend it again to the other diagonal again. Then we are going to draw the line from BFG and then extend it to the next diagonal. That is going to have CDH. So you draw this line to the main diagonals AEI. The next one BFG. The next diagonal CDH. Now also to the other diagonal or the minor diagonal, you're going to draw the line CEH. Also the other diagonal AFH. Also the other diagonal BDI. Hello. So if you succeed in drawing these lines like this, so you're going to multiply the first line, all the elements that it touched, like A, E, I. You're going to say A times E times I plus the next diagonal, that is the main diagonal now, plus B times F times G plus the other diagonal, C times D times H, all in bracket, minus the minor diagonals. So the minor diagonals, we have G multiplied by E multiplied by C in bracket plus the other diagonal, we have H multiplied by F multiplied by A plus the other one, we have I multiplied by D multiplied by B. So when you perform this operation, you are going to come out with a single number called the determinant of 3 by 3 matrix. This is what we call the rule of Sarus. Okay, now let's take an example for you to understand this. Okay, now let's go. We have let A, matrix A equal to, we have 1, 2, minus 3, 4, 5, 6, 7, 8, 9. Now we have the first column, we have the second column, we have the third column. Then we are going to repeat, or we are going to rewrite the first column as the fourth column again, and also rewrite the second column as the fifth column again. And then in our main, or in the matrix given to us, the main diagonal is what? Is 1, 5, 9. We're going to draw the line from 1 passing through 1, 5, 9. We're going to draw the line passing through this main diagonal 1, 5, 9. Go. All right. Okay. Extend it again to the other diagonal. We're going to draw the line passing through 2, 6, 7. Also draw it to the next diagonal. We have minus 3, 4, 8. Now let's go to the minor diagonal. We have 7, 5, 3. That is the minor, right? Now extend it to the next. We have 8, 6, 1. That is, we are drawing the line, arrow. Okay. Now the next one we have 9, 4, 2. Draw the line or the arrow. Okay. Now the main diagonals. The first arrow. What are the elements? We have 1, 5, 9. That means going to say 1 times 5 times 9 plus the next arrow. We have 2, 6, 7. That means going to say 2 times 6 times 7. Then plus the next arrow. We have minus 3, 4, and 8. That means going to say minus 3 times 4 times 8. Okay, this is for the main diagonal. Okay, now all this is in bracket minus then the minor diagonal. So the first one, the first arrow, we have 7, 5, minus 3. So we're going to say 7 times 5 times minus 3 in bracket plus the next arrow. We have 8, 6, 1. We're going to say 8 times 6 times 1 plus the next arrow. We have 9, 4, 2. So we're going to say 9 times 4 times 2. Okay, yes. Now let's go. Let's simplify this. When we say 1 times 5 times 9, so this is going to give us 45. Okay, yes. And then in the next one, when we say 2 times 6 times 7, it's going to give us 84. Okay, and then we'll say minus 3 times 4 times 8, it's going to give us minus 96. Then all this is in bracket. Okay, all these are in bracket. Then we have minus. In the next one, we have 7 times 5 times minus 3, it's going to give us minus 105. Then we'll say 6 times 8 times 1 is going to give us 48. And then the next one we have 9 times 4 times 2 is going to give us 72. So in the first big bracket, when you say 45 plus 84 minus 96, it's going to give us 33. And then in the other side, when you say minus 105 plus 48 plus 72, it's going to give us 15. So here we're going to have 33 minus 15, which is equal to 18. So therefore, the determinant of the matrix A is equal to that A equal to 18. All right? Yes. Okay, now let's talk about this first principle. What does it mean? Now, let's say for instance, we have a matrix given to us. You have C11, C12, C13. Okay, and then we have C21, we have C22, we have C23. We also have C31, we have C32, we have C33. So we are going to pick the first element. So what is the first element? We have C11. So what does C11 mean? It's a first row, first column. That means we are going to cover the first row and the first column. You cover the what? The first row, you cover the first column. You remember you pick it first. You pick the C11 and then you cover the first row, cover the first column. So what do you have? You have C22 and C23. You have C32 and C33. Okay, so you write down this matrix of these 2 by 2 that is left behind after when you cover. Hello, do you get this? Now you write it. Then you have, here we have plus above, right? Now C12, we have minus sign above it. So you are going to pick this C12, and then you have minus C12, right? And then C12 means first row, second column. So you're going to cover the first row and the second column. We have C12. C12 means first row, second column. That means we are going to cover first row, second column. So as you pick this C12 and cover first row and second column, so what are you going to have? You are going to have C21, C23, C31, C33. So we're going to write out these matrix. We call this the minus. Okay, now also going to the next one, we have C13. So C13 means first row, third column. So that means you pick this out and then cover the first row, the third column. First row, third column, you cover it. So as you cover it, what are the 2 by 2 matrix that is formed? Is C21, C22, C31, C32. Okay, you write it out. All right, yes. Now let's go. This is the method called the first principle. Is that clear? So as you formed the minus or the 2 by 2 matrix, the next thing we are going to do is this. We are going to do as if you want to find the determinant of this 2 by 2 matrix. You know how to do it, right? Yes. Do or try and solve as if you want to find the determinant of this 2 by 2 matrix. Okay, so we have C11 in front, right? Multiplying the 2 by 2. We have some number in front, right? Multiplying the 2 by 2, right? Now let's go. Now, if we try to find the determinant of this 2 by 2 matrix, that means we're going to say C22 multiply by C33, then minus C32 multiply by C23. Okay, this is in bracket. Then we have minus, the number outside the second matrix, that is minus C12. Now, this 2 by 2 matrix, let's also do as if we want to find the determinant. That means we are going to say C21 multiplied by C33 minus C31 multiplied by C32. Okay, all this in bracket, and then we have plus C13. So let's also try and see if we can find the determinant of this matrix. Okay, this 2 by 2. So that means we're going to say C21 multiplied by C32 minus C31 multiplied by C22. Okay, yes. Now, as it is like this, when you solve this, you are going to come out with a number called the determinant of this matrix. Okay, now let's take for instance. Now, when we talk about the rule of Sarus, we gave an example, right? Now let's use the principal method or the first principle method to find that same example to see if it's going to give us the same determinant. Okay, that means we have an example. We used the rule of Sarus and it gave us an answer 18. Now let's use the first principle to solve this to see if it is going to give us the same answer. Okay, now let's go. We have the matrix A: 1, 2, minus 3, 4, 5, 6, 7, 8, 9. All right, now let's go. The next thing we're going to do is to assign your sign, that is plus, minus, plus. Okay, now let's go. Picking the first element in the first row, first column, which is 1. So first row, first column, that means we're going to cover the first row, cover the first column. So as you cover the first row, cover the first column, what do you have? You have 2 by 2 matrix, which is 5, 6, 8, 9. You get it? Now let's go. Write it down. Now let's go to the second one. First row, second column. First row, second column. We pick 2. That means, and then the sign above it is what? Minus. That means we're going to have minus 2. So let's cover the first row, second column. Let's cover the first row, second column. So when you cover the first row, second column, what are the numbers, or what is 2 by 2 matrix that is formed? So the 2 by 2 matrix that is formed is 4, 6, 7, 9. Okay, let's write it down. Now let's go to the next one. We have first row, third column. Then we have minus 3 as the element, and the sign above it is what? Plus. So that means we're going to have minus 3. So that means we're going to cover the first row, third column. So when you cover the first row, third column, what do you have? We have 4, 5, 7, 8. Okay, now let's go. Let's try as if we can find the determinant of these 2 by 2 matrices. This matrix that is being formed, we call it the minus. The minus, okay? 2 by 2 minus of the main matrix. Now let's go. In the first matrix, 2 by 2 matrix, we can simply say 5 times 9 minus 8 times 6 in brackets. And then you know that we have 1 outside, right? Now let's go to the next one. We have minus 2, right? Now let's try as if we can find the determinant of this second 2 by 2 matrix. So if we try, we can simply say 4 times 9 minus 7 times 6. Okay, now let's go. The next one we have minus 3, okay? Let's try and see if we can also find the determinant of this third matrix. So that means we're going to say 4 times 8 minus 7 times 5. Okay, all right. Now let's go in the first one. When you say 5 times 9, it's going to give us 45. And then we have minus 8 times 6. 8 times 6 is equal to 48. Okay, now we have all this is in bracket, minus 2. In the next one, we have 4 times 9, which is equal to 36, minus 7 times 6, which is equal to 42. This is in bracket. Then we have minus 3. Now, in the next bracket, we have 4 times 8, which is equal to 32, minus 7 times 5, which is equal to 35. Okay, now let's go. We have 1. When you say 45 minus 48, it's equal to minus 3. Okay, so we have 1, open bracket, minus 3. Then we have minus 2 in bracket. We have open bracket, 36 minus 42 is going to give us minus 6. Okay, now let's go. We also have minus 3. Now the next bracket, we have 32 minus 35 is equal to minus 3. Now, we have a number and then a bracket. Let's multiply. 1 times minus 3 is equal to minus 3. Then minus 2 times minus 6 is equal to plus 12. Then minus 3 times minus 3 is equal to plus 9. So here we have minus 3 plus 12 plus 9 equal to 18. All right? Yes. So we have solved this 3 by 3 matrix. We want to find the determinant. We used the rule of Sarus. We also used the first principle. Please, I want you to watch this gradually all over and all over again for you to understand. It's very simple, okay? How to find 2 by 2, how to find the determinant of 2 by 2 matrix, and then the determinant of 3 by 3 matrix. And then 3 by 3 matrix, we talked about 2 methods that one can use. We talked about the rule of Cyrus. We also talked about the first principle. All right? Yes. Now let's take another one.